And we're back. We're going now to try to turn our English, basically, looking code into computer code in C. First of all, let's just imagine we're going to just double check and make sure the computer cannot read this code. Well, the way we tell the computer, go ahead and read the code, give it a try, this checkbox up here, they use the word verify, this checkbox in the upper left corner, that word verify, to a computer scientist, they would say what it's actually doing is compiling. And what compiling means is reading computer code and turning it into a different form of code, essentially. There's an awful lot more detail behind that, but we can just think of it as simply as that. So I'm going to hit the verify and see what happens. First, it's going to say, hey, do you want to save this? And that's always a very good idea. So I'm going to call it first_blink, save it. It's going to think about it, and then immediately it highlighted this line 13 in orange. And if I play this thing up, there's all sorts of orange text. There's a bunch of errors. These are things that the computer cannot parse, cannot understand. It's not happy with them. And this code cannot, in its current form, be sent to the Arduino because the computer can't interpret it. And by the way, it won't send code to the Arduino that the computer itself cannot interpret. So writing bad code is, you basically can't get bad code onto the Arduino board, which is good because you could imagine making a mistake where you write bad code, it has a faulty line in it, and then you push it onto this board and then this becomes cooked or destroyed in some way. You, generally speaking, don't need to be afraid of writing code that will harm your Arduino. If you really wanted to, there are some advanced tricks, you could do it. But you would need to know some very odd, specific things to write. And so it's not likely that's a mistake you're going to make. So all of this is English code, or English not code at all. Let's now make the change. First of all, we need to remove all of this from something the computer is going to try to read. We've already demonstrated that the computer can't. I'm going to select all of this stuff. I'm selecting all of my English code, and I'm going to, under Edit, I'm going to select comment/uncomment, which on the Mac is command/. What that does is it simply types 2 slashes on all those lines and makes those lines gray. This is good to know. Why is it making the lines gray? Because the computer is going to ignore everything on those lines. So we could write anything we want, good code or bad, it will ignore them. We can write English, we can write French or Spanish or Russian, it's going to simply ignore it. This gives us space to put our own actual code in here. So the actual C code will follow. The first thing we're going to write in this section is void setup, followed by a pair of parentheses with nothing in them, followed by a left curly bracket. And when I hit the enter key, the IDE, the software, does me a favor and it gives me a new line that's been tabbed in and an accompanying bracket, because these 2 brackets go together. They're matched to each other. And you'll notice, by the way, if I put the cursor by this one, it draws a little box around that one. If I put the cursor by this one, it draws a little box around that one. It is showing you which brackets match which. It is pretty trivially easy to see which bracket matches which when there's only 2 of them. But soon, when we write more complex code, we'll have nested brackets, and this will be very helpful. Inside the setup, we tell the Arduino which pin has which job. Here's the command we're going to use to do it. pinMode. And notice as soon as I typed that, it turned orange. If I got the capitalization wrong, if I typed pinMode like that, that text stays black. So the colors are actually, we're seeing a very useful guide. When things turn colors, that means it's recognized by the IDE. So it means, aha, at least I said something it knows how to interpret. pinMode. And now I'm going to have some parentheses with nothing in them. I'm going to need to fill that in. I already started typing things that I haven't explained, so I'll get rid of that. In pinMode, I'm going to type the pin number, which is 13. We already said that we have the light is attached to pin 13 blink, so turn the light on, I could have said turn pin 13 on. 13 is the pin we're going to be operating on. And then now we have to tell it what to do. or what mode to be in. And there's two possible modes. Either it's an I/O, so it's either an input or an output. In this case, we are pushing electricity out of that pin. So I write output, I have to write it in all caps. And that line is going to end with a semicolon. If you omit the semicolon, you will confuse the computer. It needs to see that there. That's in that one line, pinMode 13 output, we have accomplished what our code set out to accomplish. And the setup started here, ended there. Everything inside those setup brackets, that's the stuff that's going to run once and only once when the Arduino starts up. So that's actually all set. Now, I'm going to select all this stuff. I'm going to command / comment it out so that I can write my loop code down here. My loop. The loop is the section of the code that's going to repeat over and over and over. It looks like void setup, you'll see, except it's loop instead of setup. Why is it called loop? Because it runs in a loop. It's going to execute the instructions top to bottom, and then top to bottom, and then top to bottom ad infinitum, as long as it has power. The first thing we want to do was turn on the light, i.e. send electricity out of pin 13. How are we going to do that? digitalWrite 13 high. Now, I'm going to pause here. There's a few things that happened. digitalWrite, this was a function called digitalWrite, and I again put in the number 13 because we're operating on pin 13 and then a comma high. You can see how line 12 and line 22 look kind of similar. They have a kind of a similar syntax. They're doing different things, but you're starting to see maybe what this looks like. But I want to focus on this word high because I think it is an interesting thing to think about. There's a few different ideas that are all essentially synonyms in the world of electrical engineering and Arduino code writing. They're not truly synonyms, but we can think of them as kind of synonymous concepts. Those concepts are high, on, true, the number 1, and 5 volts. All of these things essentially are representations of the same idea in computer science. Or not, I don't want to say that's too broad. In Arduino land, we can basically think of these as all the same thing. On the other hand, are all the antonyms to that. The antonyms are low, off, 0 volts, false, and the number 0. Are they all, does true mean the same thing as the number 1? No, of course not. True is like some big idea in philosophy, but to the C programming language, they kind of do mean the same thing. And 0 kind of does mean the same thing to false. There's certainly debate to be had about that, but I just want you to have those in the back of your mind as concept. So line is going to do this thing. Now maybe you can guess how you turn the LED back off, how you stop sending electricity to pin 13. The command is going to look a lot like the one we just wrote, except it's going to have a different thing here. So it's going to be digitalWrite 13 low. So once we've done that, now we can try to execute this code, verify this code. I'm going to hit verify and problem. What's the problem? Well, let's read what the problem is. First, I want you to understand what an error is going to look like, because you're going to have errors. It's really important to be able to parse them. It says up here in the orange, expected, and then in single quotes, semicolon, before, also in single quotes, digitalWrite. Okay? That's kind of a summary or one of the errors that it encountered. What does the actual error text say? So, here it says where the sketch is, which is on the computer, and this is the name of the firstblink.ino, colon, in function void loop, so in the loop, first blink, colon, 23, comma 3. That is referring to first blink line 23, column 3, which is right where that letter D shows up, colon, error, colon, expected semicolon before digitalWrite. That is the error. And by the way, down here, it's reproducing precisely what the error looks like in context. It's saying, this is the line, and it drew this little picture below us using ASCII art. That is the thing. That thing there is what I did not like. So it's saying, I wanted to see a semicolon before the D in digitalWrite of 13 low. It's saying, I wanted to see that. But that's weird. Why does it want that? Well, because I sneakily deleted that semicolon that used to be on line 22, and the compiler is saying I need to see a semicolon before line 23, or before the digitalWrite function in line 23. So it's a little bit of a confusing error because it's not actually pointing to exactly the right spot. It's doing its best guess. You should be used to having to do a little bit of interpretive arts. So will this solve the problem? If I put a semicolon there, do you think that will make the compiler happy? That does seem to be where it wanted it. Well, it's really easy to run this kind of experiment in computer science. We just do something and then try it. Do something else and then try it. It costs practically nothing. So I can now hit verify. I want you to take a moment and imagine to yourself, is this going to work or not work? I put the semicolon in what looks to me like a pretty stupid place, but maybe it will work. Let's try it. And it actually did work. So it says, when it succeeds, it says done compiling. It gives us some information down here. Sketch uses 734 bytes, which is 2% of program storage space. Maximum is 32,256 bytes. And some information about global variables, memory. Doesn't really matter to us right now. Later, if you're writing very long sketches, you would start to care about stuff like this. So it turns out, yes, you can have that semicolon in a dumb place, and it will compile. That doesn't mean you should do it. I'm going to get rid of that semicolon in the dumb place and put it in the right place. But what if I had dumb indentation? What if I hit tab a bunch of times on that line and untab this line and maybe put some spaces in front of that thing and, I don't know, a space in there? Will it compile? Let's see. Yes, that does compile. So it turns out C is not very sensitive to spaces, and it's not very sensitive to line breaks in dumb places. There's particulars there. But we can write very ugly looking code and it will compile. That does not mean we should. So we can fix this partly using something under the Tools menu. The very top option is called Autoformat, Command T. I invite you to get very comfortable hitting Command T or Control T on a Windows machine often, because what's it going to do? It's going to fix all of the ugliness. Do you see that? The only thing it left unfixed was that little extra space, which is a matter of style. It's personal preference. So it fixes indentation problems, and that's really useful. Keeps your code looking pretty. This code compiles just like the prior code compiled, and now finally we have written code that is ready to upload to the Arduino. We know it's ready to upload because it did compile. In the next video, we're finally going to push it onto the hardware, see what happens.